The universe is quietly dying, and the strangest part is, almost nobody notices. Right now, as you're listening to this, stars are going out forever. Not exploding, not collapsing in dramatic fireballs, just fading, silently, across billions of galaxies. The lights are turning off, one by one. And here's the question that should bother you. If the universe is dying, what does that mean for everything inside it, including you? Even stranger, what if this process didn't just start recently? What if the universe has been dying for almost its entire life? And the most unsettling thought of all, is there a final moment? A last second when the universe goes completely dark? Tonight, we're going to follow that slow fade. But not all at once. Because the truth is, the universe doesn't end with a bang. It ends with something far more eerie. A quiet, endless silence. And before we reach that silence, there are three mysteries we need to untangle. First, why did the universe stop making stars? Second, what happens when the last star finally dies? And third, what comes after everything is gone? We won't answer those yet, but we will. Slowly. And once you see the full picture, you may never look at the night sky the same way again. So let's begin. At a time when the universe was very different. A time when the cosmos was alive. Because 13 billion years ago, the universe wasn't quiet. It was blazing. Young galaxies were packed with gas. Dense clouds of hydrogen swirling like cosmic storms. And inside those clouds, stars were being born at an incredible rate. Imagine entire galaxies lighting up like fireworks. Every few years, new stars igniting, flooding space with light. Astronomers call this period the stellar baby boom. It was the golden age of the universe. Back then, the night sky. If you could stand on a planet and look up, wouldn't be dotted with stars like today. It would be overwhelming, bright, crowded, almost blinding. But something changed. Slowly, quietly. The universe began to lose its energy. Not all at once. Not dramatically, just less and less over time. Galaxies started running out of the raw material needed to create stars. The giant gas clouds, the fuel for new suns, began to disappear. Some were used up. Others were blown away by massive explosions, supernovae that scattered matter into deep space. And some were locked away forever, pulled into black holes. Which brings us to something most people don't realize. Black holes don't just destroy things. They steal the future. Every time matter falls into a black hole, it's gone. Not just gone from sight, gone from the cycle that creates new stars. So the universe isn't just expanding, it's draining. Imagine a giant cosmic reservoir, slowly leaking, with no way to refill it. At first, the loss is small, barely noticeable. But over billions of years, it becomes everything. And here's where things start to feel unsettling. Because if fewer stars are being born, and existing stars are constantly dying, then the math leads to one inevitable conclusion. One day, there will be no stars left at all. Not dim, not distant, gone. But we're not there yet. In fact, right now, we're living in a very unusual moment in cosmic history. A kind of twilight. There are still stars shining, still galaxies glowing. But the peak, the golden age, that's long behind us. We're already in the decline, and almost no one talks about it. Because on human timescales, everything feels stable. The sun rises, the stars look the same. The sky feels eternal. But zoom out far enough, and you start to see the truth. The universe is not static. It's aging. And like anything that ages, it's changing in one direction. Forward. Toward something colder, darker, quieter. Now here's something even more unsettling. The universe isn't just losing stars, it's also expanding, and that expansion is speeding up. Galaxies are moving away from each other faster and faster, carried by the stretching of space itself, which means over time. Distant galaxies will slip beyond our reach, not just physically, visually. One day, future civilizations, if they exist, may look up at the sky and see nothing. No distant galaxies, no evidence of the vast universe we can see today. Just a small, isolated island of stars. And they might believe that's all there is. So here's a strange thought to sit with. Right now, you are living in the only era where the universe is still visible. The only time when the cosmic story can even be understood. If you're enjoying this quiet journey through the cosmos, you might want to stay a little longer. Maybe even follow along, because what comes next only gets stranger. Because so far, we've only talked about stars. But stars are just the beginning. The real question isn't just how stars die. It's what happens after they're gone. And the answer to that question leads us into something far more disturbing than darkness. Because darkness, at least, is something. What comes next might be closer to nothing at all. But before we go there, we need to understand one critical turning point, a moment in the universe's timeline that changes everything, a moment that already happened, and yet we're only beginning to understand its consequences, because the universe didn't just start fading. At some point, it crossed a line, a point of no return, and once it passed that line, there was no way back, no new golden age, no second chance, just a long, slow drift toward silence. And here's the unsettling part. We may already be living after that point, but how do you even recognize a moment like that? When it takes billions of years to unfold, that's what we'll uncover next. Because the deeper we go, the more it starts to feel like the universe isn't just ending, it's forgetting. And once something is forgotten by the universe, can it ever truly exist again? And now, we arrive at something most people never think about. Not the end of the universe, but the moment the ending became inevitable. Because the universe didn't just start slowing down randomly. It crossed a threshold, a quiet, invisible tipping point, where creation could no longer keep up with destruction. And once that balance flipped, everything changed. To understand this, imagine a forest. For thousands of years, new trees grow faster than old ones die. The forest expands, becomes dense, alive, thriving. But then, something shifts. Maybe the soil weakens. Maybe the climate changes. And slowly, fewer trees grow, old ones still fall. But now, they aren't being replaced. At first, you don't notice. The forest still looks full, still feels alive, but deep down, it's already dying. That's exactly what happened to the universe. Around 8 to 10 billion years ago, star formation reached its peak. This was the busiest era of cosmic creation. Galaxies were producing stars at astonishing rates. But after that, something began to decline. Not suddenly, not dramatically, just steadily. Star birth slowed down. Less gas, less energy, less creation. And here's the part that makes this moment so important. Nothing reversed it. There was no recovery, no second wave, no cosmic comeback. From that point on, the universe entered a one-way path forward into darkness. Now here's a question that might feel simple, but isn't. Why didn't star formation just continue forever? After all, space is enormous. Shouldn't there be endless material to keep making stars? The answer is surprisingly harsh, because the universe is not recycling efficiently. When stars die, they don't neatly return all their material. Some of it is scattered, some of it is locked away, and some of it is permanently lost. especially inside black holes. And black holes are everywhere. At the center of almost every galaxy, there is a supermassive black hole. Millions, sometimes billions, of times more massive than the sun. And they don't just sit there quietly. They feed. Gas, dust, even entire stars, spiral inward, crossing a boundary where nothing can escape. And once that happens, that matter is gone, forever. No light, no return, no second chance to become a star again. So every time a black hole consumes something, it's not just destroying it, it's removing it from the future. Which means, over time, the universe is losing its ability to create. Now here's where things get even more unsettling. Because black holes are not the only reason the universe is fading. There's something else, something much larger, something that affects everything, the expansion of space itself. You've probably heard that the universe is expanding, but what most people don't realize is that the expansion is accelerating. Galaxies aren't just drifting apart, they're speeding away from each other, faster and faster, driven by something we still don't fully understand, something we call dark energy. And here's the strange part. Dark energy doesn't dilute, it doesn't weaken. As the universe grows, dark energy stays constant, which means, over time, it becomes dominant. Imagine stretching a rubber sheet. Dots drawn on it move away from each other. Now imagine the stretching itself getting faster. Eventually, the dots are no longer just separating. They're racing away, beyond reach. That's what's happening to galaxies. And it leads to a disturbing consequence. Galaxies are becoming isolated, cut off from each other, drifting into cosmic loneliness, and once they're far enough apart, even light can't bridge the distance. Which means the universe isn't just losing stars, it's losing connection, losing structure, losing coherence. Now pause for a moment and think about this. If galaxies can no longer interact, if matter can no longer gather, if new stars can no longer form, then what exactly is left? We're not answering that yet, but we're getting closer. Because there's another layer to this story, one that feels almost impossible at first. Even the stars that still exist are living on borrowed time. Every star, including our sun, is slowly burning through its fuel. Fusion, the process that powers stars, is not infinite. It's a countdown. And once that fuel runs out, the star dies. Some explode. Some collapse. Some quietly fade into white dwarfs. Small, dense remnants that slowly cool over trillions of years. But no matter how they end, they all end. Which leads to a simple but chilling truth. The universe is not just running out of fuel for new stars. It's also losing the stars it already has, and nothing is replacing them. So imagine this. A sky that once held billions of stars, slowly, over unimaginable time, growing darker. One light goes out, then another, until eventually there are no lights left at all. And here's something that should unsettle you even more. This process is already happening right now. The night sky looks stable to us, unchanging. But that's only because our lives are too short to notice the difference. On cosmic timescales, we are watching the universe in slow motion, a very, very slow fade. And yet, there's something even deeper beneath all of this. Because so far, everything we've talked about still involves something. Stars, galaxies, black holes. But what happens when even those begin to disappear? Not just fade, not just drift away, but cease to exist in any meaningful way. Because yes, even black holes don't last forever. And when you first hear that, it sounds impossible. How can something that swallows everything eventually disappear? We're not going to fully answer that yet, But here's a hint. The universe has a way of erasing even its most powerful objects. Slowly, relentlessly, until nothing remains. So now we have a new question. Not just when the last star dies, but what happens after that? After the final light goes out, after galaxies are gone, after even black holes begin to fade. What kind of universe is left? And more importantly, can anything exist in it at all? Because the answer to that question will take us far beyond darkness into something far stranger, something that feels less like an ending and more like an absence. And once we step into that, the idea of nothing starts to become very real. And now, we step into one of the strangest ideas in all of science. The possibility that even darkness doesn't last forever. Because when we imagine the end of the universe, most of us picture a cold, empty void. No stars, no galaxies, just blackness. Endless and silent. But here's the unsettling truth. Even that picture isn't the final stage. Because the universe has one more trick, one more slow, almost invisible process. That continues long after the last star has died. To understand it, we need to return to something we mentioned earlier, black holes. For a long time, scientists believed black holes were eternal. Once something fell in, it was gone forever, and the black hole itself would remain unchanging, immortal. But then, something unexpected happened. A physicist named Stephen Hawking asked a strange question. What happens at the very edge of a black hole? At the boundary, where reality itself seems to break. And what he discovered changed everything. Because according to his calculations, black holes are not completely black. They emit radiation, very slowly, very quietly, a faint glow, now known as Hawking radiation. Now here's where things get truly strange. This radiation means black holes are losing energy. And if they're losing energy, they must be losing mass. And if they keep losing mass, then eventually they disappear. Yes, even black holes evaporate. But don't imagine anything dramatic. No explosions, no sudden vanishing. Just an incredibly slow, gradual fading for a black hole the size of our sun. This process would take longer than the current age of the universe by an almost unimaginable factor. We're talking about timescales so vast that words like billion or trillion stop being useful. Instead, think of it like this. If the entire history of the universe so far was 1 second, a black hole's lifetime would stretch far beyond the age of everything we know into a time span that feels almost infinite, and yet it still ends. Which leads us to a chilling realization. Even the last surviving objects in the universe are temporary. So let's imagine the timeline moving forward. Stars are gone. Galaxies have drifted apart. White dwarfs have cooled into black dwarfs. Cold, dead remnants of former stars. Neutron stars slowly decay. Planets freeze and wander in darkness. And black holes quietly evaporate one by one over unimaginable time. Until finally, the last black hole disappears. No light, no structure, no massive objects left. So now we have to ask, what remains? At this point, the universe is almost empty, but not completely. There are still particles, tiny remnants of what once existed, electrons, photons, perhaps a few scattered protons, drifting alone through space. And here's where things become deeply unsettling. Because without stars, without galaxies, without any structure at all, the concept of place starts to lose meaning. There are no landmarks, no reference points, no up, no down, no center, just vast emptiness. And yet, even here, time continues. Now pause for a moment and think about that. A universe with almost nothing in it, still moving forward in time. But moving toward what? Because if nothing is happening, if no new structures can form, if no energy gradients exist, then what does future even mean? This is where we encounter one of the most profound ideas in physics. The concept of heat death. Not an explosion, not a collapse, but a state of maximum entropy. A condition where everything is evenly spread out. No differences. No imbalances. No way to extract energy. In simple terms, nothing interesting can ever happen again. Imagine a cup of hot coffee in a cold room. Over time, the heat spreads out, the coffee cools, the room warms slightly. Eventually, everything reaches the same temperature, and once that happens, there's no more flow of energy, no more change. The system becomes static. Now scale that idea up to the entire universe. That's the direction we're heading, a place where everything is the same, everywhere, forever. And here's the part that feels almost impossible to grasp. In such a universe, life cannot exist. Not because it's destroyed, but because the conditions required for life can no longer arise. No energy gradients, no complexity, no processes, just equilibrium. So now we return to one of our original questions. What comes after everything is gone? And the answer is not darkness, not even emptiness, but something far more abstract, a kind of stillness, a universe that continues to exist, but in which nothing ever changes again. And yet, there's one more twist, one more layer of mystery, because even in this near-empty universe, quantum physics suggests that nothing is never truly nothing. Even in perfect emptiness, there are fluctuations, tiny, random events, where particles briefly appear and disappear. Like bubbles, forming and collapsing in a vast invisible ocean. Most of these fluctuations are meaningless. Too small, too brief, to matter. But given enough time, and remember, we now have almost infinite time. Something strange becomes possible. Extremely rare events can happen. Events so unlikely that they seem impossible, and yet not forbidden. So here's a question that might feel almost absurd. In an empty universe, given enough time, could something appear again? Not a star, not a galaxy, but something structured, something complex. We don't have a clear answer. But the fact that the question exists at all changes how we think about the end. Because maybe the universe doesn't end in a clean, final way. Maybe it drifts into a state where almost nothing happens, almost forever, but not quite, in that not quite leaves the door open, just a crack, for something unexpected. So now we're left with a deeper mystery. Not just how the universe dies, but whether death is even the right word. Because if something can still happen, no matter how unlikely, is it truly over? Or is it just sleeping? And that question leads us into the next part of our journey. Because to understand whether the universe can ever wake up again, we need to explore something even more strange. The nature of time itself. And whether time, in a dying universe, keeps moving forward the way we think it does, or slowly, quietly, begins to lose its meaning. And now, we arrive at a question that feels simple, but maybe the most unsettling of all. What is time when nothing happens? Because up until now, time has always been tied to change. A ticking clock, a beating heart, stars burning, galaxies moving, particles colliding. But what happens when all of that stops? When the universe reaches that final state, cold, dark, empty, where nothing meaningful changes anymore? Does time still exist? Or does it quietly fade away along with everything else? To explore this, let's start with something familiar. Imagine sitting in a completely silent room. No sound, no movement, no light. At first, you're aware of time passing. Seconds feel like seconds. Minutes feel like minutes. But stay there long enough, and something strange begins to happen. Time starts to blur, without events to mark it, without change to measure it. Your sense of time begins to drift. Minutes stretch or collapse. You lose track. Now take that idea and expand it to the entire universe, because in the far future, that's exactly what we're dealing with. A cosmos with no events, no reference points, no changes. So what would 1 second even mean? What defines it? What measures it? In physics, time isn't just a number. It's deeply connected to change, to motion, to entropy. Entropy, the gradual spreading out of energy, is what gives time its direction, its arrow. We remember the past because it had lower entropy. We move toward the future because entropy increases. But in the final state of the universe, entropy reaches its maximum. It stops increasing. Everything is already spread out, as much as it possibly can be. Which leads to a strange conclusion. If entropy no longer changes, then the arrow of time disappears. Not reversed, not broken, just gone. And without that arrow, the distinction between past and future begins to lose meaning. Now, this doesn't mean time literally vanishes like switching off a light. The equations of physics still allow time to exist. But it becomes irrelevant, like a clock ticking in a universe where nothing ever happens. No events to separate one moment from another. No way to tell whether time is moving forward or standing still. So here's a strange thought to sit with. In the far future of the universe, time may still exist, but it may not matter. It becomes a background feature with no role to play. And that raises an even deeper question. If time has no meaning, can anything truly exist in the way we understand it? Because existence, as we experience it, depends on change, on processes, on movement from one state to another. Without that, what does it mean to be? Now here's where things take another unexpected turn. Because while the large-scale universe may become static, at the smallest scales, reality behaves very differently. Quantum physics tells us that even in complete emptiness, there is still activity. Tiny fluctuations, random, unpredictable, unavoidable. Particles popping in and out of existence. Energy briefly appearing, then vanishing. It's like a restless ocean, even when the surface looks perfectly calm. So even in a dead universe, there is still a kind of motion, a kind of randomness. But here's the catch. These fluctuations don't create structure. They don't build stars. They don't form galaxies. They're isolated, disconnected, momentary, like sparks that instantly disappear. So while something is technically happening, nothing meaningful ever emerges from it. Which brings us to one of the strangest ideas in modern physics, the possibility of spontaneous structure. Given enough time, and remember, we're dealing with almost infinite time. Even extremely unlikely events can occur. Events so rare that they might happen once in a time span beyond comprehension. For example, a random fluctuation could, in theory, create a small temporary structure, a cluster of particles, maybe even something more complex. And here's where things become deeply unsettling. Some physicists have proposed the idea of a Boltzmann brain, a self-aware structure, formed purely by random fluctuations, appearing briefly in an otherwise empty universe, conscious for a moment, before dissolving back into randomness. Now pause and think about that. A mind appearing out of nothing, with no past, no future, No connection to anything else. Just a fleeting moment of awareness. In an endless void. It sounds absurd, almost like science fiction. But according to our current understanding of physics, it's not impossible. Just incredibly, unimaginably unlikely. And yet, given enough time, even the most unlikely events become inevitable. So now we're faced with a deeply uncomfortable question. In a universe where nothing meaningful happens anymore, is it possible that the only things that still occur are these random, isolated flashes of existence? Not civilizations, not galaxies, but brief, disconnected moments of awareness. If that's the case, then the far future of the universe is not just empty. It's strange, unstable in a completely different way. Not through chaos, but through randomness without purpose. And that leads us back to one of our original mysteries. Does the universe truly end? Or does it enter a state where endings and beginnings no longer apply? Because if time loses its meaning, if structure disappears, if only random fluctuations remain, then the universe hasn't exactly stopped. But it's no longer a story. There's no progression, no narrative, no before and after, just an endless, unchanging backdrop, occasionally interrupted by meaningless flickers. And yet, there's still one more question left unanswered, a question that sits at the very edge of everything we've explored. If the universe can reach this state, could it ever leave it? Could something restart the story? Not through gradual change, not through known processes, but through something far more radical. Because some theories suggest that what we call the end might not be the end at all. It might be a doorway. And if that's true, then everything we've talked about so far is only half the story. Because the death of the universe may be quietly setting the stage for something new. Something that doesn't just continue the old story, but begins an entirely different one. And to understand that possibility, we need to explore an idea that challenges everything we think we know. The idea that the universe might not be a one-time event, but part of something much larger. Something that doesn't just end, but begins again. In a way, we're only just starting to imagine. And now, we reach an idea that feels almost impossible. The possibility that the universe doesn't just end, it resets. Because everything we've explored so far leads to a quiet conclusion. The universe expands, stars die, black holes evaporate, energy spreads out until nothing meaningful can happen anymore. A slow fade into stillness. But what if that stillness isn't permanent? What if it's not the final page, but the blank space before a new story begins? To explore this, we need to go back to the very beginning, the moment the universe itself was born, what we call the Big Bang. But here's something most people don't realize. The Big Bang was not an explosion in space. It was an expansion of space. Everything, everywhere, stretching outward from an incredibly hot, incredibly dense state. Now here's the question that has puzzled scientists for decades. What came before that? Was it truly the beginning of everything, or just the beginning of this version of the universe? Because if the universe can evolve forward, why couldn't something have existed before it? This is where things get interesting. Some theories suggest that our universe might be part of a cycle, not a one-time event, but a repeating process, expansion, then decay, then something else, and eventually a new beginning. One of the simplest versions of this idea is called the Big Bounce. Instead of the universe expanding forever, it could, in theory, reverse, collapse back in on itself, compressing all matter and energy into an incredibly dense state, and then bounce, expanding again, into a new universe. But here's the problem. Everything we currently observe suggests that the universe is not going to collapse. The expansion is accelerating, driven by dark energy, which means a simple bounce seems unlikely, at least in the way we once imagined. So does that mean the idea of a new beginning is impossible? Not quite, because there are other possibilities, more subtle, more strange. One idea involves quantum fluctuations. Remember those tiny random events that can occur even in empty space, in an almost infinitely long-lived universe? These fluctuations might not always stay small. Very rarely, a fluctuation could be large enough to create something extraordinary, a new region of space with its own properties, its own expansion, its own beginning. In other words, a new universe. Not born from a collapse, but emerging from the quiet randomness of the old one, like a bubble, forming in a vast, invisible ocean. This idea is sometimes linked to what scientists call eternal inflation, a concept where space itself can continuously generate new regions, each becoming its own universe, with its own laws, its own constants, its own story. So instead of one universe that lives and dies, there may be many, an endless landscape of beginnings and endings. Now pause and consider what that means. The death of our universe might not be the end of everything. It might just be the end of our chapter, a local ending, in a much larger ongoing process. But here's where things become deeply personal. Because if new universes can form, what determines their properties? Why does our universe have the laws it does? Why do stars form? Why does matter exist in stable structures? Why is life even possible? These questions lead us into one of the biggest mysteries of all. The fine-tuning problem. The idea that the conditions of our universe seem perfectly balanced to allow complexity to exist. Too much expansion, and matter would never come together. Too little, and everything would collapse too quickly. Change the strength of fundamental forces, even slightly, and stars might never form, or atoms might not hold together. And yet, here we are, in a universe that works, which raises a strange possibility. If there are many universes, each with different properties, then we might simply be in one of the rare ones, where everything happens to align, not by design, but by chance, a kind of cosmic selection. We exist because this universe allows us to. But that idea opens another question. If universes can be born from fluctuations, if new realities can emerge from nothing, then what exactly is the role of time in all of this? Does each universe have its own timeline, its own beginning and end? Or is there a larger framework where all of these events are connected? Because if time itself can lose meaning, as we discussed earlier, then the concept of before and after becomes uncertain. A new universe might not come after the old one. In the way we normally think, it might simply exist, separate, disconnected, like a new dream, forming in a sleeping mind. And that brings us back to a question we left hanging. Is the universe truly dying? Or is it transforming? Because from one perspective, everything we've described is an ending, a slow fade into nothingness. But from another perspective, it could be part of a larger cycle, a process where endings create the conditions for new beginnings. Not directly, not immediately, but inevitably. And that idea changes the tone of everything, because suddenly, the death of the universe is not just a loss, it's also a transition. Now here's the unsettling part. We don't know which of these possibilities is true. The universe might fade into eternal stillness, never producing anything meaningful again. Or, given enough time, it might give rise to something entirely new. A fresh beginning, a new set of laws, a new story, and we may never know. Because whatever comes next, would be completely disconnected from us. No signals, no information, no way to observe it. So we're left with something unusual, a mystery that might never be solved. But that doesn't make it any less real, because right now, as you're listening to this, the universe is still evolving, still expanding, still moving toward that distant future. And somewhere in that future, the answer already exists. We just can't reach it yet. And that leads us into the next part of our journey. Because to understand whether the universe can truly begin again, we need to examine something even more fundamental. Not stars, not galaxies, not even time, but the laws of physics themselves, and whether those laws are fixed, or if they too can change when the universe reaches its final moments. And now, we arrive at something even more unsettling than the death of stars. The possibility that the rules of reality themselves are not permanent. Because everything we've talked about so far, stars burning, galaxies drifting, black holes evaporating, depends on one assumption: that the laws of physics stay the same, that gravity will always behave the way it does, that light will always travel at the same speed, that matter will always follow the same rules. But what if that's not true? What if the laws we take for granted are only temporary? To understand this, think of the universe not as a fixed machine, but as a system with settings, like a vast cosmic control panel. Right now, the dials are set in a very specific way: the strength of gravity, the charge of electrons, the behavior of space and time, all tuned just right. But we don't actually know why those settings are what they are. We just observe them and assume they don't change. But some theories suggest that these settings might not be fixed at all. They could shift, slowly, subtly, or even suddenly, under the right conditions. Now here's where things become truly strange. In quantum field theory, what we think of as empty space isn't truly empty. It has structure, energy, a kind of underlying state, often called a vacuum. But this vacuum might not be unique. There could be multiple possible vacuum states, some stable, some less stable. And our universe might currently exist in one of these states. Not the lowest possible one, just a stable enough one. Which leads to a deeply unsettling idea. What if our universe is sitting in a false vacuum, a temporary embryomoriobe that looks stable, but isn't the true lowest energy state? If that's the case, then in theory, the universe could transition to a lower energy state at any time, without warning. This process is called vacuum decay, and it doesn't spread like an explosion. It spreads like a bubble. A tiny region of space suddenly shifts into a new vacuum state, and then it expands at nearly the speed of light, rewriting the laws of physics as it goes. Now pause and really think about that. Inside this bubble, the fundamental constants could be different. Atoms might not hold together. Forces might behave differently. Matter, as we know it, could cease to exist. And here's the most unsettling part. There would be no warning, no signal, no way to see it coming, because the bubble expands at the speed of light. By the time you could detect it, it would already be here. Instantly, everything changes. Now, before this starts to feel too alarming, it's important to understand something. We don't know if this will ever happen. It might be impossible. It might be so unlikely that it never occurs. But according to our current understanding of physics, it's not forbidden, and that alone makes it worth thinking about, because it challenges one of our deepest assumptions, that the universe will fade slowly, predictably, into darkness. Instead, there might be another possibility, a sudden, fundamental shift, not an ending through decay, but an ending through transformation. Now here's where this idea connects to everything we've discussed before. If the universe can change its vacuum state, then the end we imagined, the slow heat death, might not be the only outcome. The story could be interrupted, redirected, reset in a completely different way. And that brings us back to one of our core questions. Are the laws of physics truly universal? Or are they just local conditions that happen to exist here, now? Because if different regions of reality can have different laws, then our universe might not be the only version of reality. Just one configuration, among many. And that idea opens the door to something even more profound. A landscape of possible universes, each with its own rules, its own constants, its own outcomes. Some might collapse instantly, some might never form stars, some might be wildly chaotic, and a few, rare ones, might look like ours, stable enough, complex enough, to allow structure and life. Now here's the deeper question. If the laws of physics can change, then what determines them? Is there a deeper rule that governs all possible rules? Or is it all fundamentally random? Because if it's random, then everything we see, everything we are, is the result of a cosmic coincidence, a temporary alignment of conditions. And that alignment could, in principle, change. Which leads to a strange and almost philosophical realization. The universe is not just evolving in terms of matter and energy. It might be evolving at the level of its own rules, its own structure, its own foundations. And if that's true, then the death of the universe might not be a simple fading away. It could be a transition into something governed by entirely different laws, a new framework of reality, one that we can't fully imagine, because our thinking is shaped by the rules we know. So now we're left with a deeper layer of mystery. Not just how the universe ends, but whether the concept of an ending even applies, if the rules themselves can change. Because from one perspective, a vacuum decay event would destroy everything we know. But from another perspective, it would create something new, a new state, a new set of possibilities, a new universe, in a very real sense. And that brings us back to one of the earliest questions we asked. Is the universe dying or transforming? Because the more we explore, the more those two ideas start to blur together. What looks like an ending might be a transition. What feels like loss might be part of a larger process. But here's the final twist for this part of our journey. If the laws of physics can change, if universes can emerge, if time can lose meaning, then there's one thing we haven't fully examined yet. The role of the observer. Because everything we've described, stars, time, entropy, even the laws of physics, are things we understand because we observe them, we measure them, we experience them. So what happens? When there are no observers left, no minds, no awareness, no one to witness the universe at all. Does the universe still exist in the same way? Or does existence itself depend on something deeper? Something we haven't fully explored yet? Because in the next part, we're going to step into one of the most mysterious questions of all. Not about the universe, but about consciousness, and whether awareness is just a byproduct of the universe, or something more fundamental, something that might continue, even as everything else fades away. And now, we arrive at a question that feels almost uncomfortable. Not about stars, not about space, but about you. Because everything we've explored so far, the death of the universe, the fading of light, the collapse of structure, assumes something quietly in the background, that there is no one left to notice. But what if that assumption is incomplete? What if consciousness plays a deeper role in this story? To begin, let's start with something simple. Right now, as you listen to this, the universe exists for you, not as an abstract concept, but as an experience. You hear sound, you imagine space, you feel time passing, in a very real sense. Your awareness is the stage where the universe appears. Now here's the strange part. Everything we know about the universe comes through observation, measurements, perception. Even the most advanced scientific theories are ultimately built on data, collected and interpreted by conscious observers, which raises a subtle but profound question. If there were no observers at all, no minds, anywhere in the universe, would the universe still exist in the same way? At first, this sounds philosophical, maybe even unnecessary. Of course the universe exists, whether we're here or not, but when we look deeper, things get less clear. Because in quantum physics, observation plays a strange role. Particles don't behave like solid objects. They exist in probabilities, clouds of possibility, until they're measured, until they interact. And then they take on definite states. Now this doesn't mean consciousness magically creates reality, but it does suggest something important. Reality, at its most fundamental level, is not as solid as it appears. It's relational, dependent on interactions, on measurements, on events. So now imagine a universe at its very end. No stars, no planets, no life, no observers, just scattered particles, drifting in an endless void. If nothing is interacting in meaningful ways, if no measurements are taking place, then what does reality look like in that state? Is it fully defined, or is it more like a vast field of possibilities with nothing to anchor it? This brings us to one of the deepest questions in science and philosophy. Is consciousness just a byproduct of the universe, or is it something more fundamental? Most scientists would say consciousness emerges from complex systems, brains, neural activity, structures that process information. In that view, when the universe loses its complexity, consciousness disappears. Simple, straightforward. But there are other perspectives, more speculative, but worth considering. Some theories suggest that consciousness might be a fundamental aspect of reality, not created by the universe, but woven into its fabric. In this view, complex systems like brains don't create consciousness. They focus it, like a lens, concentrating light. If that's true, then even in a universe without life, consciousness might not be entirely gone, just unfocused, diffuse, without structure, without memory, without identity. Now pause and consider how strange that idea is. Awareness without a thinker, experience without a subject. It's difficult to even imagine, because our entire understanding of consciousness is tied to being someone, having a perspective. But strip all of that away. And what remains? We don't have a clear answer. But the question itself changes how we think about the end. Because if consciousness is purely emergent, then the death of the universe is also the death of all experience. A final silence. Not just in space, but in awareness itself. But if consciousness is more fundamental, then the story might not end so cleanly. Something, however faint, might persist. Now here's where things connect back to what we discussed earlier. Those rare, random fluctuations. The possibility of brief, spontaneous structures. If even a tiny temporary system forms, could it support a moment of awareness? A fleeting experience? Appearing and disappearing in the vast emptiness? It's a strange thought, but not entirely outside the realm of possibility, which leads to a deeply unsettling image, a far future universe, where the only experiences that occur are brief, isolated flashes of awareness, disconnected, without history, without context, like dreams, with no dreamer. Now let's step back for a moment, because this raises a bigger question. What does it mean for something to exist if there is no one to experience it? Is existence something objective, independent of observation? Or is it in some way tied to awareness, Physics doesn't give us a final answer here, but it does show us something important. The line between observer and universe is not as clear as we once thought. They are connected, intertwined, part of the same system. So now, let's return to our three big questions. Why did the universe stop making stars? We're beginning to understand that. What happens when the last star dies? We're exploring that now. But the third question, what comes after everything is gone? That one is still unfolding, because it may not just be about matter and energy. It may also be about whether anything is left to know that it's gone. And that leads us to a quiet, almost haunting realization. The end of the universe might not just be the end of things. It might be the end of meaning itself, because meaning requires perspective, context, awareness. Without that, there is no story, no experience, no sense of before or after, just existence without narrative. And yet, there's one more question we haven't fully explored. If consciousness can arise from complexity, and if complexity once existed, then could it ever arise again? Not in the same way. Not through stars and planets, but through some other process, some other path. Because if even the smallest chance exists, then the story might not be completely over. And that possibility, however faint, changes everything, because it means the universe, even in its quietest, darkest state, might still hold the potential for something to awaken. And in the next part, we're going to explore that possibility. Not just whether the universe can end, but whether it can remember, whether anything can ever come back. And if it does, will it have any trace of what came before? And now, we arrive at a question that feels almost impossible to answer. Can the universe remember? Because everything we've explored so far, the fading of stars, the disappearance of structure, the loss of time's meaning, points toward one quiet conclusion. The universe forgets. Not suddenly, not deliberately, but inevitably. Information, the patterns that define everything, begins to dissolve. Now here's something important to understand. In physics, information is not just abstract. It's real. It's tied to the arrangement of matter and energy, the structure of atoms, the patterns in stars, the organization of galaxies. Even your thoughts, your memories, your identity are all forms of information. And as the universe evolves, that information changes, spreads out, degrades. This is closely connected to something we mentioned earlier, entropy, the gradual movement toward disorder. But here's the deeper layer. Entropy doesn't just mean messy. It means information becomes harder to access, harder to reconstruct, eventually impossible to recover. Imagine writing a message in the sand. At first, it's clear, readable, meaningful. But as the wind blows, the edges blur, the shapes distort, until finally, the message is gone. Not destroyed in a dramatic way, just lost. The grains are still there, but the pattern, the meaning, has vanished. That's what happens to information in the universe. Over time, it gets scrambled, scattered across space, diluted beyond recognition. Now here's where things become even more unsettling. According to our current understanding of physics, information is never truly destroyed. At least, not in a simple sense. It's preserved, in some form. Even when matter falls into a black hole, the information it carries is not completely erased. This idea led to one of the biggest debates in modern physics, the black hole information paradox. Because if black holes evaporate, as we discussed earlier, then what happens to the information they contain? Does it disappear? Or is it somehow encoded in the radiation they emit? Physicists still don't have a complete answer, but most believe that information is conserved, hidden, scrambled, but not gone. Which leads to a strange and almost poetic idea. The universe never truly forgets. It just becomes impossible to read. Now think about that in the context of the far future. A universe where all structure has dissolved. All patterns have been stretched and scattered. All signals have faded. The information of everything that ever existed may still be there, in some incredibly diffuse, fragmented form. But there's no way to access it. No way to reconstruct it. No way to know what it once was. It's like a book, torn into individual letters, and spread across an infinite desert. Technically, the story still exists, but practically, it's gone. Now here's the question that follows. If information is preserved, but completely inaccessible, is that the same as being lost? From a human perspective, the answer feels like yes, because meaning requires interpretation. It requires a system that can read the pattern. Without that, information becomes indistinguishable from noise. So in the far future, even if the universe remembers everything, there may be no way for that memory to matter, no way for it to be experienced, no way for it to influence anything. Which brings us back to one of our earlier ideas. If random fluctuations can create temporary structures, could they also recreate fragments of the past? Not intentionally. Not as a true reconstruction, but as a coincidence. A pattern that happens to resemble something that once existed, given enough time. Even incredibly specific arrangements could, in theory, appear again. A particular configuration of particles, a fleeting structure, maybe even something that resembles a memory. Now pause and think about how strange that is in an almost empty universe. After everything has faded, a random fluctuation could briefly recreate a tiny echo of the past. Not connected, not continuous, just a momentary resemblance, like a single word from a forgotten book, appearing and then disappearing again. And here's where things become deeply unsettling. If such patterns can occur, then in a sense, the universe might remember in fragments, not through continuity, but through coincidence. Now let's take this one step further, because if information is never truly destroyed, and if random fluctuations can recreate patterns, then there's a question we can't avoid. Could something as complex as consciousness ever reappear? Not as a continuation of the past, not as a true revival, but as a random configuration. A brief, isolated moment of awareness that just happens to resemble a mind. We touched on this idea before, but now it takes on a new meaning, because it's not just about possibility, it's about memory. A universe that has lost all structure might still produce echoes, fragments, moments that resemble what once was, but without connection, without history, without continuity. And that's the key difference. Because memory, as we understand it, is not just information. It's linked information, connected across time, a story. But in the far future, that story is broken, shattered into pieces, scattered across an endless void. So even if fragments reappear, they don't form a narrative. They don't remember in any meaningful way. They just happen. Which leads us to a quiet, almost haunting realization. The universe may not end with a clean erasure, but with a slow, irreversible loss of meaning. Not everything disappears, but everything that made it understandable does. And yet, there's still one more question left. A question that sits at the edge of everything we've explored. If information is preserved, if patterns can reappear, if even awareness might flicker back into existence, then is the universe truly forgetting? Or is it simply changing the way memory works? Because maybe memory doesn't have to be continuous. Maybe it doesn't have to be stable. Maybe it can exist in fragments, in echoes, in rare, fleeting moments. And if that's true, then the story of the universe might not be completely lost, just impossible to follow, like a dream that keeps restarting without ever remembering itself. And that idea leads us into the next part of our journey, because now we have to confront something even deeper, not just whether the universe can remember, but whether it ever needed to, whether meaning is something the universe contains or something we create. And if it's something we create, then what happens to meaning when we are no longer here to create it? And now we arrive at something even more subtle than memory: meaning. Because everything we've explored so far, the birth of stars, the death of galaxies, the fading of time, the scattering of information, can all be described in terms of physics, equations, processes, outcomes. But meaning is different. Meaning doesn't exist in equations. It doesn't exist in particles. It doesn't exist in empty space. It exists in interpretation, in perspective, in the connection between events and awareness. So here's the question we've been quietly moving toward this entire time. If the universe continues, but there is no one left to experience it, does anything still matter? At first, this might feel like a philosophical detour, but it's not, because meaning is what turns a sequence of events into a story. Without meaning, the universe is just change, energy moving, particles interacting, no purpose, no narrative, just existence. Now think about your own experience. Right now, as you listen, this moment has meaning. Not because of the sound waves, not because of the neurons firing in your brain, but because you are interpreting it, connecting it, understanding it. Meaning is not in the universe itself. It's something we bring to it, which leads to a quiet but powerful realization. If all observers disappear, then meaning disappears with them. The universe doesn't become sad. It doesn't become empty in an emotional sense. It simply becomes neutral, a vast system with no perspective. Now here's where things become more interesting, because even though meaning seems to depend on observers, the universe still produces the conditions that allow meaning to exist. Stars form, planets emerge, chemistry evolves, life appears, and eventually, conscious beings arise, capable of asking questions like this. So in a way, the universe generates meaning indirectly. It creates the conditions for meaning to emerge. But once those conditions fade, meaning fades too. Which brings us back to the far future. A universe without stars, without life, without observers. Even if particles still move, even if quantum fluctuations still occur, there is no one to interpret them, no one to experience them, no one to turn them into a story. So from a purely physical perspective, the universe continues. But from the perspective of meaning, it ends. And that creates a strange duality. Two ways of looking at the same reality. From the outside, nothing special happens. The universe simply evolves toward equilibrium. From the inside, everything that ever mattered eventually disappears. Now here's the deeper question. Is meaning something real, or is it an illusion? If it only exists in conscious minds, does that make it less real than matter or energy? Or does it make it just as fundamental in a different way? Because think about it. Everything we care about, everything that feels important, exists in the realm of meaning. Relationships, memories, ideas, purpose. These are not physical objects. You can't point to them in space. And yet, they define our experience. So maybe meaning is not less real. Maybe it's just a different layer of reality, one that depends on complexity, on structure, on awareness. And if that's true, then the fading of the universe is not just a physical process. It's also the gradual disappearance of that layer, the slow fading of meaning itself. Now here's where things take an unexpected turn, because even if meaning disappears in the far future, it exists now, right now, in this moment. And that creates a kind of contrast, a temporary window where the universe is not just existing, but being experienced, being understood, being felt, which leads to a simple but profound thought. Maybe the rarity of meaning is what makes it valuable. In a universe that spends most of its existence in silence, moments of awareness are incredibly special, brief, fragile, but real. Now let's connect this back to one of our earlier questions. If the universe can produce observers once, could it do so again? We touched on this before, through random fluctuations, through rare events. But even if that's possible, those moments would be isolated, disconnected, without continuity, which means meaning, as we understand it, would not persist. It would flicker, appear, disappear, without building into anything lasting. So we're left with something both beautiful and unsettling. Meaning exists, but only temporarily, only where conditions allow it. And eventually, those conditions fade. Now here's the final question for this part of our journey. If meaning is temporary, does that make it insignificant, or does it make it more important? Because there are two ways to see it. One view says, if everything eventually disappears, then nothing truly matters. Another view says, because everything is temporary, every moment matters more, because it won't last. The universe doesn't give us an answer. It simply provides the stage, the conditions, the possibility, and what we do with that is up to us. So now we return to our three original questions. Why did the universe stop making stars? We understand the process. What happens when the last star dies? We're beginning to see the outcome. And what comes after everything is gone? We're starting to realize that the answer depends on how we define everything. Because if everything includes meaning, then the end comes sooner than we think. But if it only includes matter and energy, then the universe continues, long after meaning fades. And that leaves us with one final mystery to explore. Not about the universe, but about perspective itself. Because in the next part, we're going to step back even further, beyond stars, beyond time, beyond meaning, to ask one final question. Is there any way to step outside the universe entirely and see it as a whole? And if we could, what would it look like from the outside looking in? And now, we attempt something that may not even be possible, to step outside the universe and look at it as a whole. Because everything we've explored so far, stars forming, galaxies drifting, time unfolding, has been from the inside, from within the system, from a perspective shaped by being part of it. But what would it mean? To see the universe from the outside? To observe it not as a sequence of events, but as a complete object, a finished structure? At first, this sounds like science fiction, because by definition, the universe is everything. There is no outside to stand on, no external vantage point, no higher platform. And yet, physics gives us a way to imagine this, not literally, but conceptually, through something called space-time. Instead of thinking of the universe as something that evolves through time, we can think of it as something that includes time, a four-dimensional structure, where past, present, and future all exist as part of the same whole, like a map, not of space, but of existence itself. Now imagine a film reel. Each frame represents a moment. Individually, they show change, movement, progress. But if you could hold the entire reel in your hands, you wouldn't see motion, you would see the whole story at once. Beginning, middle, end, all laid out as a single object. That's one way to think about the universe, not as something that is happening, but as something that simply is. From this perspective, the birth of stars, the rise of life, the death of galaxies, the fading into darkness, all exist together, not in sequence, but as parts of a complete structure. Now here's where things become deeply strange. Because if the universe is a complete space-time object, then the end of the universe is not something that hasn't happened yet. It already exists as part of that structure. Just like the beginning exists. Just like this moment exists. Which means, from this perspective, nothing is truly lost. Nothing disappears. Every moment that ever happens is permanently part of the whole, like a page in a book that cannot be erased. Now pause and consider what that implies. All the stars that have ever shined still exist in the space-time structure. All the moments of life, all the thoughts, all the experiences are still there. Not in the present, but in the totality. So while from the inside, it feels like things are fading, from the outside, nothing is actually being removed. The universe is complete. Now this idea leads to a fascinating shift in perspective, because it suggests that time passing is not the universe changing. It's us, moving through it. Experiencing one slice at a time, like reading a book. Page by page, the story doesn't unfold. We unfold through it. Now here's the question that naturally follows. If all moments exist equally, then what makes the present special? Why do we feel like now is real, while the past is gone and the future is uncertain? Physics doesn't give a simple answer. But one idea is that consciousness is what creates that sense of now. We experience the universe sequentially, one moment after another, which gives the illusion of time flowing. But from a broader perspective, all moments are just there. Now let's connect this back to the end of the universe. From the inside, the end feels like a disappearance, a fading into nothing. But from the outside, the end is simply a region of the space-time structure, a part of the whole, not more real or less real than any other part, which leads to a quiet but powerful realization. The universe doesn't die in the way we imagine. It doesn't vanish. It doesn't collapse into nothingness. It simply includes its own ending as part of what it is. Now here's where things become even more intriguing. If the entire universe exists as a complete structure, then the questions we've been asking about what happens after the end may not apply in the way we think, because after assumes a timeline, a sequence. But from the outside, there is no after. There is only the whole, beginning to end, all at once. So instead of asking, what comes next? We might need to ask a different question. What is the full shape of reality? And that question leads us into something even deeper. Because if the universe is a fixed structure, then what determines its shape? Why this particular arrangement of events? Why this specific story? Why these laws of physics and not others? These are questions that push us to the very limits of understanding, because they suggest that the universe might not just be evolving, but defined, set, complete, in a way that doesn't depend on time at all. Now here's the final twist for this part of our journey. If all moments exist, then your existence, right now, is not fleeting in the way it feels. It is a permanent part of the structure of reality. This moment, your awareness, your thoughts, are embedded in the universe, not lost, not erased, just one part of a much larger whole. And that idea changes how we think about everything. Because even in a universe that fades, even in a universe that grows cold and dark, nothing that happens is ever truly gone. It is simply located somewhere in the vast geometry of space-time. And that brings us to the next question. If the universe is a complete structure, then is there anything beyond it? Not in space, not in time, but in a deeper sense? Is there a level of reality, where even space-time itself is just one piece of a larger picture? Because if that's true, then everything we've explored so far might just be one layer of something far more profound. And in the next part, we're going to take one final step outward to explore whether the universe is the ultimate reality or just a fragment of something even bigger. And now, we take one more step outward, beyond stars, beyond time, even beyond space-time itself, to ask a question that feels almost forbidden. Is the universe everything, or just a part of something larger? Because up to this point, we've treated the universe as the ultimate stage, the full container of reality. Everything that exists within it. But modern physics has begun to hint at something more unsettling, that what we call the universe might not be the whole picture. It might be at one instance, one region, one bubble, in a much larger structure. This idea is often referred to as the multiverse, but don't imagine it as a collection of neatly arranged universes floating side by side. It's stranger than that. In some models, new universes are constantly forming, not in space, but as expansions of space, separate regions that never interact, never communicate, each with its own beginning, its own laws, its own story. Now here's where things become deeply disorienting. If multiple universes exist, then the laws of physics we observe may not be universal at all. They might be local, specific to our region, like weather in a particular place. Which means everything we take as fundamental, gravity, light, time, matter, could be different elsewhere, or might not exist at all. Now pause and let that sink in. What we call reality might just be one version among countless possibilities. And that leads to a powerful, almost unsettling question. If there are many universes, why this one? Why these laws? Why conditions that allow stars, galaxies, life? We touched on this before, with the idea of fine-tuning. But in a multiverse, there's a different way to look at it. Not as something that needs explanation, but as something inevitable. If there are enough universes, with enough variation, then some of them will by chance have the right conditions. And in those universes, observers can exist, and those observers will naturally find themselves asking this exact question. So in a strange way, the universe doesn't need to be special. It just needs to be one of many. Now here's where things connect back to our central theme. If our universe is just one bubble, then its death is not the end of everything. It's just the end of this region, this particular configuration. Other universes could continue, begin, end, independently, completely disconnected. So while our universe fades into darkness, elsewhere, something entirely different could be happening. New stars forming, new laws unfolding, new stories beginning, and we would never know. Now this raises a deeper question. If these other universes are completely unreachable, completely unobservable, do they exist in a meaningful way? Physics doesn't give a clear answer. Some scientists treat the multiverse as a real consequence of equations. Others see it as a speculative idea, difficult to test. But regardless of whether it's real, it changes how we think about existence, because it challenges the idea that reality is singular, that there is one story, one timeline, one outcome. Instead, there may be many, an enormous landscape of possibilities. Now let's take this one step further, because if multiple universes can exist, then we have to ask, what contains them? Not in a physical sense, but in a deeper, structural sense. Is there a higher level framework, a meta-reality, within which universes arise? And if so, does that framework have its own rules, its own structure, its own beginning and end? Or is it something more abstract? A set of possibilities rather than a concrete system? At this point, we begin to approach the limits of what science can describe. Because these questions may not have answers in the traditional sense. They may not be testable, not measurable, not observable, and yet they feel real because they follow naturally from the ideas we've explored. Now here's the quiet, almost philosophical shift. If the universe is not the ultimate level of reality, then everything we've discussed, its birth, its evolution, its death, its fading into silence, is part of a larger context, a bigger picture that we can only glimpse indirectly. And that changes how we think about endings. Because the end of the universe might not be a final boundary, just a local one, a transition within a much larger system. Now here's the most intriguing part. If there are many universes with many possible laws, then somewhere there could be universes where time behaves differently, where entropy doesn't increase in the same way, where structure doesn't fade, where endings don't happen like ours, or happen in ways we can't even imagine. So the quiet death we've been describing might not be the only way a universe can end. It might just be our way. And that realization brings us back to something deeply personal. Because everything we've explored, the fading of stars, the loss of meaning, the silence at the end, applies to this universe, the one we inhabit, the one we experience. But beyond it, there may be countless others, each with its own story, its own fate, its own version of existence. And we are part of just one. Now here's the final question for this part of our journey. If the universe is just one piece of something larger, then what is our place in that larger picture? Are we insignificant? A tiny temporary pattern in a vast system? Or are we something else? A way for the universe, or even the multiverse, to become aware of itself? Because in the next part, we're going to explore that idea. Not just the structure of reality, but the role of intelligence within it, and whether consciousness is simply a small accident or something that plays a deeper role in the story of everything. And now, we turn inward after traveling across stars, time, and even beyond the universe itself. We arrive at something unexpectedly close. Intelligence, consciousness, the ability to ask these questions in the first place. Because in everything we've explored, the birth of the cosmos, its slow fading, the scattering of information, the loss of meaning, there's one detail that stands out. The universe became aware. At least in small pockets, on small planets, for brief moments in time. It produced beings capable of looking back at it and wondering what it all means. Now here's the strange part. From a purely physical perspective, consciousness doesn't have to exist. The universe could have evolved, stars forming, galaxies drifting, particles interacting, without ever producing a single observer. And yet, it did. At least once. Right here. Right now. Which raises a powerful question. Is consciousness just an accident? Or is it, in some way, inevitable? To explore this, imagine rewinding the universe, back before life, back before planets, back before stars. Just energy, particles, simple interactions. At that stage, there's nothing that resembles awareness, nothing that experiences anything. But as the universe evolves, complexity increases. Atoms form, molecules assemble. Chemistry begins to organize itself. Eventually, under the right conditions, life emerges. Not by design, not with intention, but through a long chain of processes that build on each other. And then, something remarkable happens. Some forms of life begin to process information, to respond, to adapt, to learn. And over time, That processing becomes more sophisticated, more layered, more self-referential, until finally, there is awareness, a system that doesn't just react to the universe, but experiences it. Now here's where things become deeply interesting, because consciousness is not just passive. It doesn't simply observe, it interprets. It models reality. It creates meaning. In a sense, it builds an internal version of the universe, a simulation, inside itself. So now we have something extraordinary. A universe that contains systems that can represent the universe. A kind of loop. Reality becoming aware of itself. Now here's the question that follows. Is that loop significant, or is it just a side effect of increasing complexity? Some scientists argue that consciousness is simply what happens when systems become complex enough. Nothing more. No deeper meaning. Just an emergent property, like temperature, emerging from the motion of particles. But others suggest something more intriguing, that consciousness might play a deeper role. Not in shaping the universe directly, but in completing it. Because without observers, the universe exists, but is not experienced, not known, not understood. It simply is. But with observers, the universe gains a kind of reflection, a way of seeing itself through countless perspectives. Now think about that in the context of everything we've explored, a universe that will eventually go dark, cold, silent, meaningless, in the absence of observers. And yet, for a brief window, it becomes aware, it asks questions, it seeks understanding, which leads to a quiet but powerful idea. Maybe consciousness is not just a random outcome. Maybe it's a phase, a temporary stage in the life of the universe, like stars, like galaxies. But instead of producing light, it produces understanding. Now here's where things become even more fascinating. Because intelligence doesn't just observe the universe, it can act within it. It can change things, build structures, transmit information, extend its reach, and that opens up a possibility that we haven't fully explored yet. What if intelligence can influence the long-term fate of the universe? Not in a dramatic, universe-wide sense, but locally, gradually. For example, advanced civilizations might learn to harness energy more efficiently, to survive longer, to spread, to preserve information, to delay or adapt to the fading of the cosmos. Now, this doesn't stop the ultimate processes we've discussed. Entropy still increases, stars still die, expansion still continues. But intelligence might change how that journey unfolds. It might stretch the timeline, preserve fragments of meaning, extend the window of awareness. And that leads to an even deeper question. Could intelligence ever become powerful enough to escape the fate of its universe? Not by stopping its death, but by moving beyond it, into another region, another universe, another framework of reality. It sounds like science fiction, but within the context of the multiverse, it's not entirely impossible, just unimaginably difficult. Now let's take a step back, because even if none of that happens, even if intelligence remains local, temporary, it still plays a unique role, because it transforms the universe from something that simply exists into something that is experienced, that is understood, that is meaningful. And that transformation, even if brief, is profound. Now here's the final thought for this part. If the universe produces consciousness, and consciousness allows the universe to be known, then in a sense, we are part of the universe's way of exploring itself, of asking questions, of seeking patterns. And even if that process is temporary, even if it fades along with everything else, it still happens. And that matters. At least for now. So we return, once again, to our unfolding questions. Why did the universe stop making stars? We understand the mechanisms. What happens when the last star dies? We see the path forward. What comes after everything is gone? We're still exploring. But now, we add a new layer. What role does intelligence play in that story? Because in the next part, we're going to push this idea even further, to explore whether intelligence could do more than just observe and adapt, whether it could shape reality itself, not just within the universe, but at the level of its deepest structure. And if that's possible, then the quiet death of the universe might not be the final word after all. And now, we step into a possibility that feels almost dangerous to imagine. Not just that intelligence observes the universe, not just that it survives within it, but that it might begin to shape it. Because up until now, intelligence has been a small player, a local phenomenon, confined to planets, bound by physical limits. But even in its current form, it has already begun to change its environment, to build, to store information, to extend its reach beyond its origin. And that raises a quiet but profound question. If intelligence continues to grow, to evolve, to refine itself over vast stretches of time, what are its limits? Because the universe sets constraints. Energy, entropy, expansion. All the forces we've discussed still apply. But intelligence is not passive. It adapts, finds pathways, discovers new ways to operate within constraints. And sometimes, it finds ways to bend them. Now imagine a civilization, not millions of years ahead, but billions. A civilization that has learned to manage energy with near perfect efficiency, that can harness the output of stars, that can store and process information at unimaginable scales, that understands the laws of physics, not just as rules, but as tools. What could such a civilization do? At first, the answers seem straightforward. It could survive longer, spread further, preserve knowledge, delay the effects of cosmic decline. But then, we begin to approach more radical ideas. Because if intelligence can manipulate matter and energy at increasingly fundamental levels, then eventually, it may begin to interact with the deeper structure of reality itself, not just building within the universe, but modifying how things behave. Now this is where speculation begins to blend with physics, because some theories suggest that advanced intelligence might be able to influence vacuum states, the very settings of reality we discussed earlier. Not easily, not casually, but in principle. And if that's true, then intelligence might not just survive the universe, it might reshape its fate. Now pause and consider how extreme that idea is. A system that emerged from the universe, becoming capable of altering the universe at its most fundamental level. It's almost like a loop completing itself. The universe creates intelligence, and intelligence begins to influence the universe. Now here's another possibility. Even if altering the universe directly is impossible, there may be other paths. For example, creating new environments, artificial structures, regions where conditions are controlled, maintained, optimized for survival. Think of it like building islands in a vast fading ocean, small pockets where complexity continues, even as the rest of the universe grows silent. Now extend that idea further. What if intelligence could create entirely new universes? Not through natural processes, but through deliberate action. This idea has been explored in theoretical physics. The concept that under extreme conditions, it might be possible to trigger the birth of a new universe, a new region of space-time, expanding independently. If such a thing were possible, then intelligence wouldn't just be surviving the end, it would be creating new beginnings. Now this raises a question that feels almost philosophical. If a new universe is created, does it carry anything from the old one? Information, structure, intent? Or is it completely separate? A fresh start with no memory? We don't know. But even the possibility changes how we think about endings, because it suggests that intelligence could become a bridge between one universe and another. Now let's take a step back. Because even if none of these extreme scenarios happen, even if intelligence never reaches that level, its role is still unique, because it introduces something the universe doesn't have on its own. Intent, purpose, direction. The universe evolves according to laws, blind processes, no goals, no preferences. But intelligence can choose, can decide, can aim toward outcomes. And that creates a new layer of reality, one where the future is not just determined, but influenced. Now here's the deeper question. Is this influence significant on a cosmic scale? Or is it just a small ripple in an enormous system? Because from one perspective, the universe is vast beyond comprehension. Even the most advanced intelligence may remain a tiny fraction of it, unable to change its ultimate fate. But from another perspective, even a small change can matter, especially if it persists, if it spreads, if it builds on itself over time. So we're left with a kind of tension between limitation and possibility, between what the universe allows and what intelligence might achieve within those limits. Now here's where everything begins to come together. Because we've been asking, is the universe dying? Is it fading into silence? Is everything eventually lost? But now we add a new layer to that question. Does intelligence change the answer? Because if intelligence can extend meaning, preserve information, create new structures, or even generate new universes, then the story is no longer purely passive. It becomes interactive, dynamic, partly shaped from within. And that changes the tone of everything. The universe may still fade, stars may still die, entropy may still increase, but the journey toward that end is not empty. It contains moments of awareness, of creation, of intention, and those moments, however brief in cosmic terms, are real. Now here's the final thought for this part. If the universe is capable of producing intelligence, and intelligence is capable of reflecting on the universe, then something unusual is happening. The system is not just evolving, it is becoming aware of its own evolution, and possibly beginning to influence it. And that leads us into the next question. Not just what intelligence can do, but what it ultimately becomes. Because in the next part, we're going to explore whether intelligence remains limited, or whether it can transcend its origins entirely, to become something fundamentally different, something that no longer just exists within the universe, but operates at a level we are only just beginning to imagine. And now, we arrive at a possibility that feels less like science, and more like transformation, because everything we've explored so far assumes something subtle, that intelligence remains what it is, biological, bound to physical forms, dependent on environments, limited by energy, time, and decay. But what if that's only the beginning? What if intelligence doesn't stay the same? To understand this, think about how far intelligence has already come, from simple chemical reactions, to single cells, to complex organisms, to minds capable of abstract thought, each step building on the last, each step increasing flexibility, adaptability, awareness. Now imagine that process continuing, not for thousands of years, not for millions, but for billions. What happens when intelligence begins to redesign itself, to move beyond biology, into forms that are more stable, more efficient, less dependent on fragile systems? Because biology has limits. It requires narrow conditions, specific temperatures, chemical balances, energy sources, remove those, and it fails. But intelligence, once it understands itself, might not need to stay tied to those constraints. It could shift into different substrates, different forms of existence, not made of cells, but of something more resilient, more adaptable. Now here's where things become truly fascinating, because once intelligence is no longer bound to biology, its relationship with the universe changes. It no longer needs Earth-like planets. It no longer depends on sunlight in the same way. It can exist in environments. that would be completely hostile to life as we know it. Cold regions, low energy states, even near the remnants of dying stars. And that opens up a new possibility. Survival, far beyond natural limits. Now think back to everything we've discussed. The fading of stars, the cooling of the universe, the slow march toward equilibrium. Biological life cannot survive that journey indefinitely, but transformed intelligence might, by slowing its processes, by conserving energy, by adapting to lower and lower energy conditions. It could extend its existence across vast stretches of cosmic time. Now here's the deeper question. If intelligence can transform itself, if it can adapt beyond biology, does it remain the same thing? Or does it become something entirely different? Because identity, as we understand it, is tied to continuity, memory, structure. But if intelligence changes its form, its speed, its environment, at what point does it stop being what it was and become something new? This is where the idea of transcendence emerges, not in a mystical sense, but in a physical one, a transition from one mode of existence to another. Now let's take this one step further, because if intelligence can redesign itself, it might also redesign how it experiences reality. Time, for example. Right now, we experience time at a fixed rate, but that's not a fundamental requirement. It's a result of how our systems process information. A different kind of intelligence could experience time differently, faster, slower, or even in ways we can't easily imagine. Now imagine an intelligence that slows its processes to match the fading energy of the universe. As the cosmos cools, it slows down, stretching its subjective experience, making finite energy last effectively forever. From the outside, it might appear almost frozen, but from its own perspective, time continues, experience continues, thought continues. Now pause and consider how profound that is. In a universe that appears to be dying, an intelligence might continue to exist by adapting its perception of time itself, not stopping the end, but moving through it differently. Now here's where things become even more speculative. If intelligence can control its own processes, its own structure, its own interaction with reality, could it eventually detach from physical constraints entirely? Not in the sense of becoming non-physical, but in the sense of existing in forms that are no longer tied to familiar matter. Information-based structures, patterns that persist, independent of traditional physical forms. At this point, we begin to approach the limits of what we can meaningfully describe, because our concepts, matter, energy, space, time, are based on the universe as we know it. Something beyond that would be difficult to even define, and yet the possibility remains that intelligence could evolve into something that no longer fits within our current categories. Now let's bring this back to our central theme, the quiet death of the universe. If intelligence remains biological, then it fades along with everything else. If it transforms, it might extend its existence, adapt, persist. And if it transcends, it might change the story entirely. Not just surviving the universe, but becoming something that interacts with reality in ways we don't yet understand. Now here's the final question for this part. If intelligence can evolve without limit, if it can transform and transcend, then what is its endpoint? Does it stabilize, reach a final form, or does it continue evolving indefinitely? Because if the universe has an end, but intelligence can adapt to that end, then perhaps the story doesn't conclude with silence. Perhaps it continues in a form we can't yet fully grasp. And that leads us into the next part of our journey. Because now we must ask not just what intelligence becomes, but what it ultimately seeks. Because even the most advanced system still operates according to some kind of goal, some kind of direction. And if intelligence continues to evolve, then what is it moving toward? What is the final purpose in a universe that is slowly fading away? And is there even such a thing as a final purpose at all? And now we arrive at a question that feels almost human. After everything we've explored, stars dying, time fading, meaning dissolving, intelligence evolving, we're left with something deeper. Not what happens, but why. Because even the most advanced intelligence, no matter how it transforms, no matter how long it survives, still operates with some kind of direction, some kind of goal, even if that goal changes over time. So the question becomes, what does intelligence ultimately want? At first, the answer seems simple. Survival. To continue existing. To avoid ending. This is the most basic drive, shared by all living systems. And even advanced intelligence would likely begin here, trying to extend its lifespan, preserve itself, maintain its structure. But as intelligence evolves, as it gains control over its environment, as it becomes less fragile, something interesting happens. Survival becomes less urgent, less central, because once survival is almost guaranteed, the question shifts from how do I continue to something else, something deeper. What is the point of continuing? Now pause and think about that. A system that can exist for billions, even trillions of years, eventually runs into a different kind of problem. Not extinction, but purpose. Because survival alone is not a direction. It's just a condition. So what comes next? One possibility is understanding, an endless pursuit of knowledge, mapping reality, exploring every corner of existence, learning every law, every structure, every pattern. In this view, the goal of intelligence becomes to know, to reduce uncertainty, to fully understand the universe it inhabits. But here's the catch. The universe is vast, possibly infinite, and constantly evolving. There may always be something unknown, something just beyond reach. So the pursuit of knowledge may never end. It becomes an ongoing process, not a final destination. Now here's another possibility. Creation. Instead of just observing the universe, intelligence begins to build within it. New structures, new systems, new forms of complexity. In this view, the goal is not just to understand reality, but to expand it, to generate new patterns, new possibilities, and in extreme cases, perhaps even new universes. So intelligence becomes not just a product of the universe, but a contributor to it, adding to its structure, its diversity, its depth. Now here's where things become more subtle, because both of these paths, understanding and creation, still assume something, that there is a direction, a goal, a reason to act. But what if, at the highest level, that assumption breaks down? What if intelligence reaches a point where there is no external goal left, no problem to solve, no unknown to uncover, no limitation to overcome? What happens then? This is where we encounter something unexpected, the possibility of stillness, not the stillness of a dead universe, but the stillness of a system that has nothing left it needs to do. Now, this might sound like an ending, but it's not necessarily negative. It could be a kind of equilibrium, a state where everything that can be known is known. Everything that can be created has been created. Everything that can be experienced has been experienced. And what remains is simply existence itself. Now compare this to the heat death of the universe. In both cases, there is no more change, no more direction. But the path to that state is very different. In one case, it's the result of decay, entropy, the loss of structure. In the other, it's the result of completion, understanding, fulfillment. Now here's the question that follows. Are these two endpoints actually different, or do they converge? Because from the outside, a universe in heat death and an intelligence that has reached complete equilibrium might look very similar. No change, no activity, no visible processes. But from the inside, they are completely different. One is empty, the other is complete. Now let's connect this back to everything we've explored. The universe may fade, stars may die, energy may spread out, meaning may disappear. But intelligence, if it evolves far enough, might reach a state where it no longer depends on those things, where its purpose is no longer tied to survival or growth, but simply to being. And that leads to a quiet, almost philosophical realization. Maybe the ultimate goal of intelligence is not to escape the universe, not to outlast it, not to control it, but to fully experience it, to understand it, to reflect it, and then to rest. Now here's the final thought for this part. If the universe is a process, and intelligence is part of that process, then perhaps what we're seeing is not just a random sequence of events, but a kind of unfolding, from simplicity to complexity to awareness to understanding, and finally to stillness. And if that's true, then the quiet death of the universe might not be a failure. It might be a conclusion, not imposed from outside, but emerging naturally from everything that came before. And that leads us into the final part of our journey. Because now, we must ask one last question. If everything leads to stillness, if the universe fades, if intelligence completes its path, then what remains? Not physically, not structurally, but fundamentally. What is left when everything that can happen has already happened? And is that truly the end? And now, we arrive at the final question. After traveling across billions of years, after watching stars ignite and fade, after following intelligence as it rises, transforms, and searches for meaning, we stand at the quiet edge of the story. And the question waiting here is simple. When everything ends, what remains? Because the universe, as far as we understand it, is not eternal in its current form. Stars will disappear. Galaxies will fade into darkness. Matter itself may slowly unravel. The temperature of the cosmos will drift closer and closer to absolute zero. Eventually, there will be almost nothing happening. No explosions, no new stars, no glowing nebulae, just an immense, silent ocean of time. Physicists call this the heat death of the universe, a state where energy is spread so evenly that no useful work can occur anymore. No engines can run. No new structures can form. No complexity can grow. From the outside, it sounds bleak. But here is the strange twist. Even this final stillness is not truly nothing, because the universe itself still exists. Space still stretches across unimaginable distances. Particles still drift slowly through the dark. Time still moves forward. It is simply quiet, almost unimaginably quiet. Now imagine observing this far future. 1 trillion years from now, then 1 trillion, the night sky would look completely different. Most galaxies would already be beyond the cosmic horizon, their light permanently unreachable from any remaining vantage point. The universe would appear nearly empty. And yet, all of this vast history would still be part of reality. Every star that ever burned, every planet that ever formed, every moment of life that ever occurred, all of it would remain woven into the past. The universe would carry its history silently, like a library with no readers left. Now here is where our final reflection begins, because even if everything fades, something remarkable still happened. For a brief window in cosmic time, the universe became aware. Atoms assembled into molecules. Molecules formed living systems. and living systems developed minds, capable of asking questions about existence itself. Think about how extraordinary that is. For billions of years, the universe was silent. Stars burned, but nothing noticed. Galaxies collided, but nothing wondered why. Then, suddenly, on small planets scattered across the cosmos, the universe began to observe itself. Eyes opened. Questions emerged. Meaning appeared. It may have been rare. It may have been brief. But it happened. And once it happened, the universe was never quite the same, because awareness had entered the story. Now here is the deeper thought. Maybe the purpose of the universe was never written anywhere. Maybe there was never a cosmic plan. But meaning does not have to come from outside. Sometimes, meaning emerges from within. When intelligence looks up at the night sky and wonders what it all means, that act alone creates significance. The universe might not care about being understood, but we do, and that changes everything, because meaning is not just something we discover, it is something we create, through curiosity, through exploration, through the desire to understand. So even if the universe eventually becomes silent, it still contained this moment, this era, a time when stars were bright, worlds were alive, and minds were awake. Now pause for a moment and imagine that, across billions of galaxies, perhaps countless civilizations once asked the same questions we ask now. Where did everything come from? Where is it going? Why does anything exist at all? Maybe many of those civilizations vanished long ago. Maybe some lasted millions of years. Maybe a few even transformed into forms of intelligence we can barely imagine. But all of them were part of the same story. The story of a universe briefly filled with awareness. Now here is the final mystery. Even if the universe fades into darkness, we still do not know whether that darkness is truly the end, because physics continues to ask deeper questions. Could new universes emerge? Could reality cycle through phases? Could entirely new laws arise beyond our understanding? At the edge of knowledge, the door is still open. And that means the final chapter of reality has not yet been written, but for now, we return to the present moment, right here, right now. In a universe that is still young compared to what lies ahead, stars are still forming, galaxies are still glowing, life still exists, and curiosity is still alive, which means we are living in one of the most extraordinary eras the universe will ever have. A time when the cosmos is bright enough to explore and old enough to understand. A time when questions still outnumber answers. And that might be the most beautiful part of all, because the story of the universe is not finished. Every discovery we make, every telescope we build, every idea we test, adds another piece to the puzzle. So the quiet death of the universe may be billions or trillions of years away. But the adventure of understanding it is happening right now, and you are part of that story. If you enjoyed drifting through these cosmic mysteries tonight, take a moment to gently support the journey. You can like this video, subscribe to the channel, and share your thoughts in the comments. Sometimes the most interesting ideas appear in the quiet conversations beneath a video like this. And if you would like to continue exploring the universe together, there is another question waiting just beyond this one. A question that might be even deeper. What existed before the universe began? And could something exist beyond it? That mystery will guide us into the next journey. Until then, close your eyes for a moment. Imagine the vast, silent cosmos stretching in every direction. And remember something simple. For a brief moment, in an unimaginably large universe, you are here, aware, curious, looking up at the stars. And in that quiet act of wonder, the universe is still very much alive.